Hello students, in today's lecture we are going to learn about vectors and this is theory part 1. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So, topic is vectors. So, here question arises, what is vectors? So, imagine you have an arrow. You have an arrow like this. And the length of the arrow is this. This is the length of the arrow, is the magnitude, and the this sign, or we can say this indicates the direction. Which one? This. So suppose the arrow is this one. So the part from here to here is the length and this shows the direction. So it means what? It means vectors is a physical quantity which has both magnitudes and directions. So here question arises, what is magnitude? Magnitude just a number like 10, 5, 6. Magnitude just a number. So in physics we can classify quantities as scalars or vectors. We know scalars is a physical quantity which has only magnitudes, but vectors is a physical quantities which has both magnitude and direction. How? Suppose we have a 10 kg sugar. 10 kg sugar. It means the magnitude term is only 10. It means it shows the mass, or we can say quantity. So this is just scalar. Now what is vectors? So suppose a car moving with 10 kilometer per hour. So here the speed of the car is 10 kilometer. So it shows only direction. But if we talk about the car moves 10 kilometer per hour in east direction, so it shows the velocity, or velocity is a vector quantity. So it has both magnitude and direction. So it is vector. Clear? Basically, the difference is that a direction is associated with a vector, but not a scalar. If we talk about vector, so there is a direction, and it talk about scalar, so there is only magnitude. Scalar quantity is a quantity which with magnitude only. Scalar quantity is a quantity with magnitude only. It is specified completely by a single number. So what is magnitude? Just any number, or just any single number, that is magnitude. So along with proper unit. So the mass of the body is suppose 10 kg. 10 kg. So here kg is what? Kg is the unit, and what is the magnitude? Magnitude is 10. For example, the distance between 2 points. So suppose we have a 2 points, a point A and point B. Point A and point B. So the distance between these 2 points is a scalar quantity, because here only magnitude. Another example is mass of an object, temperature of body like 10 Kelvin, 5 Kelvin. 5 shows the magnitude and Kelvin is unit of the temperature, and time. So these are the examples of scalars: distance, mass of an object, temperature, and time. So at at any given time, suppose at any given time, uh, the position of an object is changes. The position of the object is changes with respect to time. In that case, we say the speed. What is speed? Rate of change in position with time of any object. But if we include in this any direction like east direction, west direction, then in that case it becomes vector or speed, or we can say it is velocity. It has both magnitude and direction. The rules for combining scalars are the rules of ordinary algebra. Like suppose we have a two numbers, 4 and 5 is equal to, when we add both numbers, is equal to 9. Simply we can add scalars. Suppose 10 kg plus 2 kg, 12 kg. So using simple ordinary algebra, we can add scalars. Scalars can be added, subtracted, multiplied, and divided just as the ordinary numbers. We can add, subtract, multiplied, and divide like a ordinary numbers. So scalars means just a number with along a unit. For example, if the length and breadth of a rectangle are 1.0 meter and 0.5 meter. So length, if we talk about a rectangle, the length is 1.0 meter and 0.5 meter. Clear? Then what about then its perimeter is the sum of lengths of four sides. So we add easily 1 plus 0.5 plus 1 plus 0.5. So it gives perimeter of rectangle, that is 3.0 meter. Now 3.0, so it is here magnitude is 3 and unit is meter. The length of each side is a scalar and the perimeter is a also scalar because it has only magnitude. Clear? Take another example. The maximum and minimum temperatures on a particular day are 35.6 degrees Celsius. Look at here. Here this shows the temperature of on a particular day. So 30.56 is a magnitude term and degree Celsius, C is the unit, or we can say degree Celsius. And another temperature is, minimum temperature is 24.2 degrees Celsius. So then what will be the difference? So difference between the two temperature is 11.4 degrees Celsius. Similarly, if a uniform solid cube of aluminium of side 10 centimeter has mass of 2.7 kg, then its volume is 10 raised to the power minus 3 meter cube. So it is a scalar quantity. And its density is 2.7 into 10 raised to the power 3 kg per meter cube. And it is also scalar. It means from the given example, we can say scalars can be easily add and subtract or multiplied and divide. I hope this is clear. Vector. We already know a vector is a physical quantity that has both a magnitude and a direction and obeys triangle law of addition. In upcoming lectures, we will learn briefly about the triangle law of addition or equivalent the parallelogram of addition. So we know vector is a physical quantity which has both magnitude and direction. So a vector is specified by a giving its magnitude by a number and its direction. Some physical quantities that are represented by vectors like we have a displacement is a vector quantity, velocity is a vector quantity, acceleration is a vector quantity, and force is a vector quantity. So these are the examples of vector quantity. Clear? To represent a vector, listen carefully, how we can represent a vector. So to represent a vector, we use a bold space type. Suppose we have a term like V and here V is bold. So we can say V is a vector. Thus a vector, or we can say like a velocity vector, can be represented by a symbol V. The another method to represent a vector, suppose we have a acceleration. So acceleration is represented by A. So here A is just a number or we can say magnitude. But if we put an arrow on A, so it will be now become acceleration. So this is the representation of a vector quantity by a arrow by bold face. Clear? Now we will learn some vectors like position vectors and displacement vectors. Position vector means it shows position of any object of any point. Displacement vectors shows the change in position of two different particles with respect to reference frame. Clear? So to describe the position of an object moving in a plane, so here a question arises, what is the meaning of plane? Plane means two dimension, like a x axis, one dimension. X axis means one dimension. If two dimension are present like x and y in same time, so we can say it is a two dimension. Now to describe a position of an object in a plane, we need to choose a convenient point and say O as a origin. So look at figure A. So here the convenient point is O. And let P and P prime be the positions of the object at time t and t prime respectively. So in figure A, we have a object. We have an object, and the position of that object's initial position is P prime, P, and final position is P prime. Then what it shows? So if we talk about only the point P, listen carefully. If we talk about only point P from O to P, OP. So here OP represent the position of any particle or we can say of an object. OP is the position. Similarly, OP prime, OP prime is the it shows the position of an object, or we can say position of a particle, and from the reference point is O, or we can say reference point is origin. So the distance is from the origin is R. If we talk about the particle situated at point P, from the origin R, and the position R prime, the particle situated at point P prime, from origin O. So R and R prime is the position vectors. What it shows? It shows position vectors. Now, what about the displacement vector? So we join O and P by a straight line. Then OP is a position vector of the object at time t, and an arrow is marked at the head of this line. Now it is represented by symbol R. So OP equal to R. So this is only position vector. Now, so P prime is represented by another position vector OP prime and denoted by R prime. The length of the vector R represents the magnitude of the vector and its direction, and its direction in which P lies as seen from O. We already discussed it. If the object moves from P to P prime, listen carefully. If the position of the object changes from P to P prime, the vector P prime with tail at P and tip at P prime. So here important point is this. Look at here, this arrow. So this position is tail and this position is tip. So tip at have at P prime and tail at a P. Now the P prime is called position vector, displacement vector. Is called what? Is called displacement vector. Why we call it is displacement vector? Because P prime shows the changes of the position of the particle at two different with respect to time. Clear? So P prime is the displacement vector. Suppose if there is a another part, suppose the particle changes position again, and the position of the particle is this one, and suppose we choose the position of particle is n, and from the origin this one, suppose the position is this one, n position. So and the position vector is R double prime. So what will be the displacement? So if we talk about the displacement vector, so it will be P to P prime, draw a arrow, so it will be Pn. Pn is a displacement vector of particle which changes position from P to n. Now I hope this is clear. So the displacement vector corresponding to motion from point P at time t to point P prime at time t prime. So this is the all about the displacement vector. So it is important to note that displacement vector is the straight line joining the initial and final positions. So look at here in figure A. What is the initial position? The initial position is at P, and final position is P prime. Yes or no? So displacement vector is the straight line joining initial and final positions, and does not depend on the actual path undertaken by the object between these two positions. This point is very important. How? Actual path, it means what? Suppose the particle, the initial position is at P, and after some time it changes the position to at point P prime. Then after some time again it changes the position from P point to again P. So here the initial position is P, and final position of the particle is again P. Yes or no? Initial and final position both are same. In that case, the displacement of the vector is, or we can say displacement of the particle is 0. Why? Because initial and final position are same. It means displacement vector depends on initial and final position. It does not depend on path. It depends only on initial and final position. If the initial and final position both are the same, in that case the displacement of the particle is equal to 0, because it form like a cycle. And if a particle move like a cycle, in that case the displacement is also 0. Now I hope this is clear about the position vector and displacement vector. So for example, given the initial and final positions as P and Q, look at figure B. So the initial position is P and final position is Q of an particle. Initial position P and final position Q. The displacement vector is same PQ. The displacement vector is PQ for different paths of journey. Suppose the path of journey is P, A, B, C, Q. Look at here. P, A, B, C, Q, and then again P. So in that case, the path is same in all. In that case also, P, D, P, D, and Q, and P, B, E, F, and Q. So in all path P, A, B, C, Q, P, D, Q, and P, B, E, F, Q, the path is same. It means the position vector is only PQ, and the initial and final position is same. So we can say the displacement of the particle is 0. Therefore, the magnitude of displacement is either less or equal to the path length of an object between 2 points. It means displacement can be 0, positive, or negative. Clear? Equality of vectors. Here the word is equality, means equal. So what is the meaning of equality of vectors? Suppose we have two vectors, A vector and B vector. A and B vector. We know the representation of vector is, suppose we have an arrow and length of the arrow is shows the magnitude and this shows the direction. So the A vector OP is vector A and QS vector B. Two vectors A vector and B vector are said to be equal if the condition is what? And only if they have the same magnitude and same direction. Look at here in figure A. So A vector and B vector, the length of the vector are the same, so we can say the magnitude is same, and the direction is same. Both are parallel to each other, so we can say this is equal vector. Suppose we draw another vector c vector, and the length of the vector c is equal to length of the vector a and length of the vector b. In that case, a, b, c are equal vectors. Why? Because the magnitude and directions of the vector a, b and c are equal or same. So this is the concept about the equality of vectors. Figure A shows two equal vectors, a vector and b vector. We can easily check their equality by the direction and by the length of the arrow. Shift B parallel to itself until its tail Q coincides with the with the tail of A. So Q coincides with O. Since their tips S and P also coincide, so two vectors are equal. So we can say A vector equal to B vector. Look at here. In general, equality is indicated as A vector is equal to B vector. Note that in figure B, A vector prime and B vector prime have the same magnitude. The length of the arrow are same, but they are not equal because they have different directions. So the direction of the both vector A prime vector and B prime vector are different. That's why they are not equal. So this type of vector are we called unequal vector. Even if V shifts B prime parallel to itself so that its tail Q prime coincides with tail O prime of A prime. The tips S prime of B prime does not coincide with the tip P prime of A prime. So this is an example of unequal vectors. Now we will learn about the multiplication of vectors by real numbers. Look at here, there is a two vector, A vector and 2A vector. So multiplying a vector A with positive number lambda, any number 1, 2, 3 doesn't matter, any positive number gives a vector. It means what? It means suppose we have a vector A, if we multiplied in vector A with 2, so it become 2A vector. So it 2A 2 times of vector A. So this is also a vector quantity. It means it does not depend on the any magnitude values. So lambda gives a vector whose magnitude is changed by the vector lambda, but the direction is the same as that of A. So here important point is this is a vector and this is also a vector, but the magnitude of the both the vectors are different, but direction are same because of both are parallel to each other, because both are parallel in same direction. So mode of lambda A is equal to lambda comes outside, so it will be equal to lambda mode of A, but the condition is what? Lambda should be greater than 0. For example, if A vector is multiplied by 2, the resultant vector 2A is in the same direction as A and has magnitude twice of mode of A as shown in figure A. Look at here. So this is the term about the multiplication of vectors by real numbers. I hope this is clear. So look at figure B. Multiplying a vector A by any negative number, that is suppose the negative number is minus lambda, or we can say -1, -2, -5, -7, any negative digit gives another vector whose direction is opposite to the direction of A and whose magnitude is lambda times mode of A. So here we have a vector A vector and now multiplied uh, by minus a, it become minus a vector. What will be the change? The change is only the direction is opposite. Both are opposite. If another vector, suppose a vector, by multiplying by minus 1.5, so the direction of both the vectors are same, but their magnitude is different. So this is the all about the multiplication of vectors by any negative number. Multiplying a given vector a by negative digits, say minus 1 minus 1.5, gives vector as on figure b. I hope now this is clear. Thank you for your attention.